Howdy guys, this lesson is going to be a really fast introduction into scatterplots, basically just how you can read them. So this is part of our statistics unit that we're not going to be able to cover this year, just with multiple subs and then the pacing of the remote learning. We just aren't getting to our statistics unit, but I did want to at least show you how you read a scatterplot, just so you'll be prepared. This would also help you out in science as well, okay? So a scatterplot is a graph that is made of a bunch of different individual points, and they're not necessarily like in a straight line. And they're just kind of all over the place. And then you're trying to look at those individual points and determine overall what is happening to the data that it's showing you. Okay, so let me show you an example. So here we have a graph. I don't know what it's about because there's no information on the X or the Y axis, but overall I can see all these different points. So each point would represent a person's response to whatever this question was. And overall, I can see that the data is trending down. It's trending negatively. So this has a negative slope to it, okay? The points are, not super close together, but it's obvious to see that it's trending down. It's trending negatively. So this would have a correlation that is considered strong. So a strong correlation would mean your points are close to being in a straight line. The weaker the correlation of something is, the less obvious it is to see that straight line with your points. Okay, so this would have a strong correlation because it's easy to tell that it's trending down. A weaker correlation, your points would be more spread out and more scattered, hence the term scatterplot. Okay, so there are oftentimes these little points that are kind of not in the general trend of your data, and they are called outliers. And outliers are important. They're an important piece to the graph, but they're considered outliers because they don't follow necessarily the trend of the graph, but it doesn't take away from it. So if you covered up this point right here, your data is still trending down. You can see that. Okay, so this point, it's not that it doesn't matter, it just doesn't affect what is happening to the majority of your data. Okay, so this question right here says, which best describes the type of association shown in this scatter plot? So no association, your scatter points, they're going to be all over the place. You're not going to be able to tell that they're trending up or they're trending down. Okay, nonlinear is going to have a curve in it. It's going to make a shape, but it's not going to be a straight line. Okay, and then positive linear would be a graph going in the positive direction. And I know this is covering it down here, but negative linear would be going down. It would be trending down. So if I drew a straight line inside these points, you could tell that that straight line would be going down. So this is a negative linear association. Okay, let's look at a few more examples. So this one says, what type of association does the following graph have? Positive linear, negative linear, no association, or nonlinear. Okay, so positive linear, remember it would have a positive slope. It would be going up. This data looks like it is going down. Okay, the dots aren't all over the place. They are very close together. I would say even closer than the ones in this graph. There's obviously more points here as well, so more individual pieces of data being shown. So this, I would say, has a stronger correlation than this previous graph that I showed you. The points are closer together. It's even easier to see that it is trending down. This is a negative association. There's a couple points in it that are considered outliers. Remember, that's important, but they don't take away from what the general trend of the graph is doing. Okay, so this would be a strong negative linear association. All right, so this example right here, it is strong. Those points are really close together. And this time it's going in the positive direction. So from left to right, it's going up. So this would be a positive linear association with a strong correlation. If the points were more spread out, it would have a weaker correlation. Okay. So let's look at another example. So this type of association here, I can't tell that the points are going up. I can't tell that they're going down. They're just kind of all over the place. So when those points are all over the place, they're considered no association. Okay, you can't tell what the points are doing. You can't tell as X is getting bigger, Y is getting smaller, bigger, larger, whatever, and vice versa. As X gets smaller, what's happening to Y? You can't tell. They're just all over the place. Okay, so this would be no association. And then let's look at an example that would be non-linear. Okay, so this graph right here is going to be non-linear. So I can tell it's non-linear because it has this curve. If I tried to show you a line that was happening with this graph, it would have a curve or a bend in it. So it's non-linear. Okay, but you can see that there's still a pattern. It's not no association. You can see pretty much X gets bigger, Y gets bigger up until this point. And then as X gets smaller, X gets bigger, Y is getting smaller. So there's something happening. Part of it is positive and part of it is negative. So this would be a non-linear because there is some kind of trend in the data, but it is not a linear trend. It's not a straight line. Okay. And so you could relate this to what's going on in the world right now. This is, what we're hoping is happening with everything related to COVID-19. The cases are rising, right? But at some point, we hope it reaches its peak and they start falling. That's why this whole stay-at-home order is to try to get the cases to go down and try to help our healthcare workers. But that would be a non-linear association because it would have a curve in it. It's rising, but then at some point, we hope it decreases and falls off. Okay, so that would be non-linear. And let's look at this example. It says, Bridget drew the trend line shown in the following scatter plot. So remember I told you if you were drawing lines in the point, what would be like happening to that line? Would it be a positive or a negative slope? So Bridget drew this trend line. So that's what that line is called, is a trend line. And it's also called the line of best fit. Same thing, trend line or line of best fit. So she drew the trend line up here. Okay. And just the trend line should be in the middle of all the data. Okay. So when I say that, there's probably some of you that are like, well, that trend line right there is not in the middle of the data. The trend line should be a little bit lower. So you want roughly half the points above the trend line and half the points below the trend line or the line of best fit. Okay. So we don't like where this trend line is placed. Bridget didn't put it in a good spot. So let's see if we can figure out why. So the trend line is not a good fit for the data because there is an outlier. So we have this outlier down here. Okay, remember the outlier is important, but it doesn't affect where the line goes because we kind of just ignore it. It's not in the main part of the data. It's out there all by itself. And this trend line should be roughly in the middle of all the points that are close together. Okay, so it should have about half the points above it and half the points below it. So it doesn't matter that it doesn't matter that there's an outlier. Okay, the trend line is too high because it's not in the middle of the data. So let's look at B. The trend line is not a good fit for the data because most of the data points are below the trend line. This is correct. Most of the points on this graph are below, and we said that the trend line or the line of best fit should be in the middle. So it should have about half the points above and half the points below. Okay, so we know B is the correct answer, but let's keep going. The trend line is a good fit for the data because it passes through two of the data points. It doesn't matter how many points actually touch the line. Okay, so it has a point here that it's going through and a point here. That has nothing to do with it. It's all about it being in the middle of the data. Okay, the more points that touch the line, the stronger your correlation would be, right? Because that would mean they're even closer together. But the fact that it's going through two doesn't mean that the trend line is good. Okay, and then D, the trend line is a good fit for the data because the data represents a positive association and the line has a positive slope. Well, I do agree that it has a positive association. It does have a positive slope, But the trend line, it doesn't matter if it's positive or negative. What matters, it's in the middle of all the data, and this one is not. Okay? So let's look at this example. It says, how are these two related? Hours spent watching TV and test grades. Okay, so think about that for a second. Okay, my guess is that you are in agreement with me that for most people, the more hours you spend watching TV at home after school, the lower your test grades are going to be, probably because you're not studying, right? So the more hours you spend watching TV, the lower your test grade, okay? So as your hours spent watching TV goes up, your test grades go down. That would be a negative correlation, okay? And let's say that you are the student that you never study for your test. You go home and you just watch TV all night, all evening, all afternoon, and then you make 100s on your test grades. Well, you would be considered an outlier in this case because that is not most people. Most people have to study to get good test grades. So if you are spending more hours watching TV, your test grades would go down. That would be a negative correlation. Okay. All right, let's look at these two. So education and income. Okay, education and income. What kind of correlation do you think that these two have? Okay, in general, and there are a lot of outliers with this one, but in general, the more education that you have, the higher your income, right? We can all think of different examples of people that maybe don't have as much education, but they're making millions and millions of dollars. Think about YouTubers that are still in high school and, they don't have a high school diploma yet, but they're making a lot of money. That would be an outlier. Okay. So this one has a lot of different outliers that could happen, but in general, the more education that you have, the higher your income would be, and that would be considered a positive correlation. Okay, so you could think of an outlier in this instance with education and income, but in general, the higher your education, the higher your income. Okay, and then the last thing I just want to introduce to you, if you have a scatter plot, I'm going to go back to this one, and I asked you to find the slope. Some of you would be like, how am I supposed to find the slope of that? So the first thing that you would do, if you are given a scatter plot and you are asked to find the slope or the rate of change, remember those are the same thing, is you need to draw a trend line or line of best fit. Okay, so you're going to draw a line in between all of the data where you have about half the points above and about half the points below. Okay, so I have this data here with temperature and sales. Okay, we'll say sales of ice cream because it doesn't say. And I drew the line of best fit or the trend line in between all of that data. Okay, now when you have to count the slope, you don't care about each individual scatter point. Okay, you don't care about each individual point. You were only looking at the line of the graph, the linear line. Okay, pick 2 points on the line and count the slope, the rise over the run between those 2 points. Okay, so you're not looking at these individual, the blue points. Now you're only looking at your straight line, your line of best fit or your trend line, and you're counting the slope between those. So your rise over your run. That is how you would find the slope or the rate of change on a scatter plot. Okay, I know this was a really fast introduction into this. I hope that helps you at least understand how do you determine if a correlation is strong or weak, and then how do you know the association on a graph. If you know those two things, at least it's a little bit something That should help you out with Math 1, and it also will help you out in science.